Hello and welcome to another coding session with Rune. Today we'll be working on FPCache. It's a new idea of mine. I want to make it a little series in which we'll create a small little simple tool and get it shipped to cargo or crates.io so you can actually install it for yourself and see how it was made, right? The idea is very simple. File processing cache. It will cache a file operation, right? So say we have a little tool. It takes a lot of time to process a file. Let's say a command that counts the amount of letters of A in a file. I don't know, right? The idea is that FPCache can store the result in a cache, and then instead of running the command again on the file, you can just get it from the cache, and the cache will obviously be invalidated when the file changes or gets edited. We'll see exactly how later. For now, I just want to start working on it. So I already got like a very simple little repo that has a pre-made standard Rust library and a pre-made standard Rust binary. So I set that up and I made a little commit of the initial workspace. Let's say add rustfmp.tml. Okay. So this is just a very basic cargo workspace setup, right? And it ignores just target for now. So what I want to work on is first to get a nice CLI going, right, for us. And then once we add features to the CLI, we work on expanding the library. So this is how I feel you should do software engineering. You don't make like a high level design at first. Just start by designing your iteration plan, right? So my iteration plan is we kind of know what it does. We kind of have an idea of what it does, right? Just keep track of a cache, or we will work on the CLI first, and then once we are happy with the API, kind of how it looks, we'll see how the functionality will actually be implemented. So that's exactly what I'll be doing in this video. I'll just be making a simple CLI. It doesn't do anything yet, but I'll show you how to use clap to make a CLI, right? That's the goal of this video. So let's get started. So clap, first thing we do is we go to our cargo toml and we cargo add clap, right? Not only that, but we want the derive feature, right? Because that just makes things a lot more easy for us. So you see how much it added already, right? Like it uses sign, quote, proc macro, the standard stuff. You just have to know that sometimes sign takes a long time to compile. So if you're unhappy with your compilation speed, use cargo build -- timings, and if it shows sign being a big bottleneck, it can take up to 10 seconds, right? Don't use it. Just manually implement all that stuff, because really you don't need to run the proc macro every time. If you know how it's implemented, just implement it yourself. You don't need sign to write it for you. Anyway, so I added clap, and what you can see here is that I added it to the CLI toml because I don't expect it to be a workspace, like a shared dependency of any kind, right? So I see here it uses version is 4.5.53. Unnecessary in my opinion. We're just going to depend on version 4. And why do I do that? It makes it like, I know clap uses semver properly, and every no matter what you use, it will be backwards compatible. So yeah, hi, it's me from the future. Obviously I forgot to use the caret operator, which in semver means that, hey, 4.5 is okay, and anything above it, 4.6, 4.7, is also okay, right? Because in semver, those are backwards compatible. This will disallow version 5 and above, which is how you should do things. And similarly, if you're adding like new dependencies with a 0 point, then you're disallowing 0.7, right? You're only allowing patch version. So this is how you should do it, and I obviously forgot in the video. So yeah, that's a quick interjection. Okay, so that's clap added. It has the derive feature, and then we can get started actually creating our argument struct. So how clap works is every argument you add after your CLI will get parsed by the clap parser. So we first of all, we import it. Now this is a derive. You see, it's a derive. We want to derive it above our argument struct. Okay. And what this is going to do, let's check if Rust Analyzer is running. It is. What it's going to do is this is going to be, it's going to represent your whatever it comes after it, right? So for now, I just want FPCache, right? Let's just have a test argument. So we will have this. I think it's an enum. Enum command. Test like this. I think it's this, and then we need to derive clone on it, apparently. Clone, like so. Value parser doesn't exist because we need to specify to clap that this is actually parsable as a command. And the way we do that is by deriving subcommand on here and specifying that this is a subcommand. So let's do that. Subcommand. Don't know where you pull subcommand from, but I'm guessing it's just from this same clap. Yes, it is. Okay, so that should be fine. Doesn't satisfy 7 bounds. That's okay. Let's specify that this is a subcommand. Okay, and I mean this would already work, but we want we can give like metadata to our program, right? So for example, you can do stuff like this and stuff like this. Right, so I'm just adding a description, and you'll see in a second like how this shows up in the actual binary. Okay. So now we should actually be able to do this. So let args equals args here. I think stop parse. I'm not really sure. Ah, there we go. So this will panic, I think. Yeah, see, it exits on an error. So either you parse properly or you just die. And then what we can say is we usually have a match statement, right? So match args.command. And then you can match on data passed to our CLI tool. And so in this case, if it's test, we'll just say, hey, I'm here. And then we're good. So this should already work. So let's try it out. Nope. Okay, that was good. And then we can do cargo run. And cargo run will just run the actual thing. I like personally installing it so you can actually get the actual feel of the CLI. So let's create an install script. I'm going to do this at the root. I'm going to call it local install.sh. And all this will do is when cargo install at this path, we'll probably have to use this path, right? FPCache CLI. And I think that's it. I'm not too sure. I think it's this. Let's try it out. Yeah, see virtual manifest. You want FPCache CLI. Okay. And so this will create an executable FPCache CLI for us. Let's make this executable. Okay, good. So now we can just run this every time we want to install and run our thing. So now we can do FPCache CLI, and then it will show the things that we just coded here. Right, so again, what's it showing here? It will show a file processing utility. That's our about here. It will use, it will show up the commands that you can use, right? So test shows up because it was a subcommand. Okay, seems pretty good for now. And one more thing, I noticed that when installing, it showed FPCache CLI. I just want it to be FPCache. So we go to the cargo toml and we just simply rename the binary output. And now that we removed CLI from here, we can actually just run this again to install FPCache executable. Now we have this, right? So FPCache will show test and help. Well, before leaving, there's two more things we have to do, right? So one is actually commit our changes, add a test command, and an install script. So add test command, right? We'll just stash this. Add test command, add install script. Okay, so now we've committed to the repo, I mean the local repo, right? And second of all, let's actually verify that it works. There you go. So now I'll see you in the next video. Bye bye.